नमस्ते दोस्तों, स्मार्ट माइंड्स ट्यूटोरियल्स में आपका स्वागत है। आइए आज कुछ नया सीखें।
So let us get started with inverse trigonometric functions. So first I will show you a few points to remember. These are the important points to remember in this chapter.
Okay.
So the domains and ranges of the inverse trigonometric function are given in the table. So I will give you function and its respective domain and range.
Okay.
We captured the light. So let us take the function y is equal to sine inverse of x. Its
Okay.
domain is closed interval minus 1 comma 1. Closed interval means the corners are included. And
Okay.
its range is minus pi by 2 to pi by 2.
Okay.
Then the function is y equals cos inverse x. Here also domain is minus 1 comma 1 and range is 0 comma pi. Y is equal to cosecant inverse x. Domain is r minus open interval minus 1 comma 1. That means it takes all real valued functions, all real numbers except for minus 1 and plus 1 in the open interval, and the range will be closed interval minus pi by 2 comma pi by 2 minus 0. That means it takes all the values from minus 90 to plus 90 excluding 0.
Okay.
We have y is equal to secant inverse x. This is r minus open interval minus 1 comma 1 and here closed interval 0 comma pi minus pi by 2. And y is equal to tan inverse x. So the domain is all real numbers and the range is open interval minus pi by 2 comma pi by 2. Open interval means the corners are excluded and
Okay.
closed interval is the corners are included. Now y is equal to cot inverse x. Domain is r and range is open interval 0 comma. So the value of an inverse trigonometric function which lies in its principal value branch, which is also abbreviated as PVB, that is called as principal value of that inverse trigonometric functions. So
Okay.
over here, I have given you some important formulae like sin x whole inverse can be written as 1 by sin x. But sin inverse x cannot be written that way. So always remember sin x whole inverse is completely different from sin inverse x. Then y equals sin inverse x. That means x can be written as sin inverse y. Okay. Then
Yes.
if sin x is equal to sin y, that means y is equal to sin inverse x.
Okay.
Okay. Then sine of sin inverse x is equal to x. Then
Okay.
sine inverse of sin x equals to x. Then
Okay.
tan inverse x minus tan inverse y, we have a formula that is tan inverse of x minus y by 1 plus xy.
Okay.
Then 2 tan inverse x equals tan inverse of 2x by 1 minus x square. Now we have three different formulae for 2 tan inverse x. That is, one is in the form of tan, other is in the form of sine, and the other is in the form of cos. In
Okay.
terms of tan, we can write it as tan inverse of 2x by 1 minus x square. In terms of
Okay.
sine, we can write it as sine inverse of 2x by 1 plus x square. Then in terms
Okay.
of cos, it can be written as cos inverse of 1 minus x square by 1 plus x square. These are the important formulae from this chapter, which we will be using in the problems.
Okay.
Let us continue with exercise 2.1. So we
Okay.
need to find the principal values of the following. So the first question is sine inverse of minus 1 by 2. So let's say sine inverse of minus 1 by 2 equals to theta. Then we can
Okay.
write minus 1 by 2 as sine theta. So when is sine theta 1 by 2? At 30 degrees. So 30 can be written as pi by 6 in radians. So this can be written as minus sine pi by 6 equals sine theta. Now minus sine pi by 6 can be written as sine of minus pi by 6, which is equal to sine theta. Why? Since sine of minus x equals minus sine x.
Okay.
Now we already know that since the range of principal value branch of sine inverse is closed interval minus pi by 2 to pi by 2. So therefore, theta equals minus pi by 6. Hence, principal value of sine inverse of minus 1 by 2 is minus pi by 6. Take the next question, cos inverse of root 3 by 2.
Okay.
So let's say cos inverse of root 3 by 2 equals theta. So root 3 by 2 can be written as cos theta. Now when is cos theta root 3 by 2? At cos 30, and 30 can be written as pi by 6 in radian form. So cos pi by 6 equals cos theta. Now since the range of principal value branch of cos inverse is closed interval 0 comma pi. So therefore theta is equal to pi by 6. Finally we can conclude, hence principal value of cos inverse root 3 by 2 is pi by 6. Take the third question, cosecant inverse of 2. So let's say cosecant inverse 2 equals theta. So 2 equals cosecant theta. When is cosecant theta 2? At cosecant 30 degrees. 30 can be written as pi by 6. That is
Okay.
equal to cosecant theta. Now since the range of principal value branch of cosecant inverse is closed interval minus pi by 2 to pi by 2 excluding 0. So therefore we can say theta equals pi by 6. Hence principal value of cosecant inverse 2 is pi by 6. Take the next one, tan inverse of minus root 3. So let's say tan inverse of minus root 3 equals theta. So minus root 3 can be written as tan theta. Now root 3, how can we write in terms of tan? We can write it as tan 60. So 60 can be written as tan pi by 3. That equals to tan theta. And also we know that minus tan theta can be written as tan of minus theta. That is equal to tan theta. Since
Yeah.
tan of minus x is equal to minus tan x. Now, since the range of principal value branch of tan inverse is minus pi by 2 comma pi by 2. Therefore, theta is equal to minus pi by 3. Hence, principal value of tan inverse of minus root 3 is minus pi by 3. Take the next question, cos inverse of minus 1 by 2. So let cos inverse of minus 1 by 2 is equal to theta. That means minus 1 by 2 can be written as cos theta. Now 1 by 2 can be written as cos pi by 3. That is equal to cos theta. Now minus cos theta can be written as cos 180 minus theta.
Okay.
Since cos pi minus x is equal to minus cos x. So we know that if we take LCM, pi minus pi by 3 will become 2 pi by 3. So this is 2 pi by 3 equals cos theta. Now, since the range of principal value branch of cos inverse is closed interval 0 to pi. So therefore we can say theta is equal to 2 pi by 3. 2 pi by 3 is 120 degrees. Hence, principal value of cos inverse of minus 1 by 2 is 2 pi by 3. Take the next question, tan inverse of minus 1. So let tan inverse of minus 1 equals to theta. So minus 1 can be written as tan theta. Minus 1 can be written as tan 45. 45 can be written as pi by 4 in radian measure. So that is tan theta. Now tan minus tan 45 can be written as tan of minus 45 equals to tan theta. Since tan of minus theta equals to minus tan theta. And since the range of principal value branch of tan inverse is open interval minus pi by 2 comma pi by 2. Therefore, theta equals minus pi by 4. Hence, the principal value of tan inverse of minus 1 is minus pi by 4. Take the next question, secant inverse of 2 by root 3.
Okay.
So let's say secant inverse of 2 by root 3 equals theta. So we can write 2 by root 3 as secant theta. Now 2 by root 3 can be written as secant pi by 6, that is secant 30, which is equal to secant theta. Since the range of principal value branch of secant inverse is closed interval 0 to pi minus pi by 2. So therefore, theta is equal to pi by 6. Hence we can say the principal value of secant inverse of 2 by root 3 is pi by 6. Take the next question, cot inverse of root 3. So let cot inverse of root 3 is equal to theta. So root 3 can be written as cot theta. Now when is cot theta root 3?
Pi by 6.
At 30 degrees. So pi by 6 equals cot theta. So since the range of principal value branch of cot inverse is closed interval 0 to pi. Therefore, we can say theta is equal to pi by 6. Hence, the principal value of cot inverse root 3 is pi by 6. Take the next question, cos inverse of minus 1 by root 2. So let's say cos inverse of minus 1 by root 2 equals theta. So minus 1 by root 2 is cos theta. Now minus 1 by root 2 can be written as cos pi by 4. And we can see that minus cos theta can be written as cos 180 minus theta. That is cos pi minus pi by 4 equals to cos theta. Why? Since cos pi minus theta can be written as minus cos theta. Now, if we take LCM, we get pi minus pi by 4 as 3 pi by 4 equals cos theta. So, theta equals 3 pi by 4. Since the range of principal value branch of cos inverse is closed interval 0 to pi. Therefore, theta equals 3 pi by 4. Hence, principal value of cos inverse minus 1 by root 2 is 3 pi by 4. Take the next question, cosecant inverse of minus root 2. So let cosecant inverse of minus root 2 equals to theta. So minus root 2 can be written as cosecant theta. Now minus what is root 2? Root 2 can be written as cosecant pi by 4. That is equal to cosecant theta. Now we know that minus cosecant theta can be written as cosecant of minus theta. Since cosecant of minus x is equal to minus cosecant x. Now, since the range of principal value branch of cosecant inverse is closed interval minus pi by 2 to pi by 2 minus 0. So therefore, theta equals pi by 4. Hence, principal value of cosecant inverse of minus root 2 is minus pi by 4. Now let us find out values of the following. Question number 11 is tan inverse of 1 plus cos inverse of minus 1 by 2 plus sin inverse of minus 1 by 2. So let us find all these three terms individually and then we will add it up. So first let us find out tan inverse of 1.
Okay.
So let's say tan inverse of 1 is equal to some theta.
Yeah.
So tan theta is equal to
1
so tan theta is equal to pi by
pi.
4. Tan pi by 4.
Okay. Pi by 4.
Wait a minute. Here we don't have to find the principal values. So let's see a different way. Let tan inverse of 1 plus cos inverse of minus 1 by 2 plus sin inverse of minus 1 by 2 is equal to y, let's say. Or we can say tan inverse of 1 plus the second term we will take as some theta and the third term we will take as some phi is equal to y. So theta is equal to theta is cos inverse of minus 1 by 2 we have taken and phi we have taken as sine inverse of minus 1 by 2. Let's take this as equation number 1. Now we have cos inverse of minus 1 by 2 equals. So minus 1 by 2 is cos theta. And so minus cos pi by 4 equals to cos theta. Now minus cos pi by 4 we can write cos pi minus pi by 4. That is cos 3 pi by 4. Cos 3 pi by 4. One minute. Here you have 1 by 2. 1 by 2 is 60.
We can even do in an easier way by doing principal branching.
Yeah, you can do that way also. So pi minus pi by 3. Over here you get pi by 3. And this is cos pi minus pi by 3. So that is 2 pi by 3. Cos 2 pi by 3 equals to cos theta. So we got theta as 2 pi by 3. And this is equal to cos inverse of minus 1 by 2. Take this as equation number 2. Why? Since principal value branch of cos inverse is 0, pi. And sine inverse of minus 1 by 2 we have taken as phi. So we can write minus 1 by 2 as sine phi. Now when is sine theta 1 by 2 at 30 degrees? So this is sine pi by 6 equals to sine phi. So this can be written as sine of minus pi by 6 equals to sine phi. So phi equals minus pi by 6. That is equal to sine inverse of minus 1 by 2. Let's take this as equation number 3. Since principal value branch of sine inverse is closed interval minus pi by 2 to pi by 2. Now using these three equations, equation number 1, 2 and 3. Now using equations 1, 2 and 3, what do we get? Y equals tan inverse of 1 can be written as tan pi by 4 plus 2 pi by 3 plus minus pi by 6. So that is equal to pi by 4 plus 2 pi by 3 minus pi by 6. So that is 3 pi plus 8 pi minus 2 pi divided by 12. So that is 9 pi by 12, which is equal to 3 pi by 4. Take the next question. Cos inverse of 1 by 2 plus 2 sine inverse of 1 by 2. So let's say cos inverse of 1 by 2 plus 2 sine inverse of 1 by 2 equals to y, let's say. Or we can take this cos inverse of 1 by 2 as some theta plus 2 into sine inverse of 1 by 2 we can take it as some phi equals to y. So theta we have taken as cos inverse 1 by 2 and phi we have taken as sine inverse 1 by 2. Let us take this statement as equation number 1. Now we have cos inverse of 1 by 2 equals to theta. So 1 by 2 we can write it as cos theta. Now 1 by 2 can be written as cos pi by 3 because it's 60, cos 60, which is equal to cos theta. Now theta equals to pi by 3, that is cos inverse of 1 by 2. Take this as equation number 2. Since principal value branch of cos inverse is closed interval 0 to pi. And the same way, we take sine inverse 1 by 2 as phi. And we can write 1 by 2 as sine inverse phi. When is sine theta 1 by 2? So this phi can be written as sine 1 by 2, or 1 by 2 can be written as sine phi, not sine inverse, okay? So this is sine pi by 6 equals sine phi. So phi equals pi by 6. That is sine inverse of 1 by 2. Equation number 3. Now using all the three equations, equation 1, 2 and 3, we get y equals pi by 3 plus 2 into pi by 6. So 2 ones are 2 threes are. So pi by 3 plus pi by 3 is 2 pi by 3. 2 pi by 3 is 120 degrees. So 2 pi by 3 is the answer. Take the next question. This is an MCQ. If sine inverse x equals y, then which option is correct? He's asking us. So now let's say what is given to us? Sine inverse x equals y. That means x equals sine y. Now, since principal value is minus pi by 2 less than or equal to y less than or equal to pi by 2. Therefore, B is the correct option. Correct option is B.
Why is Inverse on this?
Take the next question. Even this is an MCQ. Question number 14. Tan inverse of root 3 minus secant inverse of minus 2 is equal to dash.
छोटे से डब्बे में
Tan inverse of root
पहले
3
भी गाना देता है
minus secant inverse of minus 2
इधर की भी लाइट
equals to y, let's say. Or we can tan inverse of root 3 can be written as tan pi by 3 minus secant inverse of minus 2 equals to y. Or we can write y as pi by 3 minus theta, where theta we have taken as secant inverse of minus 2. So now we know that secant inverse of minus 2 is theta we have taken. So minus 2 is secant theta. Or minus secant pi by 3 equals secant theta. Now minus secant theta can be written as secant pi minus theta. Same as we do in cos. So theta equals 2 pi by 3. That is secant inverse of minus 2. Since principal value branch of secant inverse is 0, pi closed interval minus pi by 2. So using equations 1 and 2, what do you get? Y equals pi by 3 minus 2 pi by 3. That is pi minus 2 pi by 3. That is minus pi by 3, which is option B.